Picture a factory worker in Detroit in 1965, pressing steel panels into the body of a Chevrolet with a machine that weighed more than most houses. Every door, every hood, every quarter panel came out of raw steel. Heavy, solid, built like a vault. That car might rust, but it would not crumple easily. And for decades, nobody questioned whether steel was the right choice. It just was. By the end of this video, you'll know exactly why that changed and what replaced the steel that once made American cars feel like they were built to last a century. Steel ruled American car manufacturing for most of the 20th century for one simple reason. It was strong, it was cheap to form into complex shapes, and the United States had plenty of it. General Motors, Ford, and Chrysler all built their production lines around steel. It was the backbone of the entire industry. Then came the 1970s. The oil crisis hit American consumers hard. Suddenly, a car that weighed 2 tons and got 10 miles per gallon was not a selling point. It was a problem. Automakers had never been forced to think seriously about weight before because fuel was cheap and buyers rewarded size and power. The crisis changed the equation overnight. Lighter meant cheaper to run, and that started a conversation about whether steel was the only answer. That conversation moved slowly through the 1980s and 1990s, partly because steel production costs were rising and alternatives were getting better. But the real pressure came from the government. The corporate average fuel economy standards, known as CAFE standards, set a target that eventually climbed to 54.5 miles per gallon by 2025. That number forced every automaker to find weight wherever they could cut it. Here is where the engineering trade-off gets interesting. Aluminum can be up to 50% lighter than steel. According to the Aluminum Association, every 10% reduction in a vehicle's weight improves fuel economy by 6 to 8%. For an automaker trying to hit a government-mandated mileage target across an entire lineup of vehicles, that is not a small number. That is the difference between passing a federal test and failing it. Ford made the move that got everyone's attention. In 2015, the company switched the body of the Ford F-150 to aluminum. The F-150 is the best-selling vehicle in the United States, so this was not a quiet experiment. It was a very public bet that aluminum could handle the same abuse that truck buyers expected from steel. Ford's former chief executive, Mark Fields, put it plainly, saying the company was making a commitment to innovate, to reduce vehicle weight, and to improve fuel efficiency. General Motors began making similar moves across some of its own models. The reaction from buyers and critics was not all positive. Some industry experts raised serious questions about long-term durability and what happens when aluminum gets dented or damaged in a collision. Steel, when bent, can often be straightened by a body shop with basic equipment. Aluminum behaves differently. It requires specialized tools, specific techniques, and technicians who have been trained to work with it. That gap in repair knowledge drove up costs for owners, and it still does. A fender bender that might cost a few $100s to fix on a steel-bodied car can cost significantly more on an aluminum-bodied one, depending on the shop and the severity of the damage. The shift also hit workers hard. Steel workers in the Midwest watched the demand for traditional steel in auto manufacturing begin to shrink. The socioeconomic concern was real. Communities that had built their economies around steel production for the auto industry found themselves facing a changing market with fewer jobs in the exact roles that had supported them for generations. Steel manufacturers did not simply walk away from the competition. Companies, including United States Steel Corporation, began developing higher-grade steel products, stronger and lighter than traditional steel, designed specifically to compete with aluminum. These advanced high-strength steels offer better performance than older steel grades while still being lighter than conventional steel. Many modern vehicles actually use a combination of materials, with aluminum in some panels and advanced high-strength steel in structural areas where its properties are better suited. Then came electric vehicles, and they changed the equation again. Battery packs in electric vehicles are extremely heavy. A large battery pack can add significant weight to a car compared to a traditional engine and fuel tank. That weight penalty makes every pound saved elsewhere in the vehicle structure worth more in terms of range. As of 2024, electric vehicle manufacturers are pushing into carbon fiber and other advanced composite materials to keep total vehicle weight as low as possible. According to a report by Markets and Markets, the global automotive lightweight materials market was valued at $70 billion in 2020 and is projected to reach $130 billion by 2027. That growth reflects how far this shift has gone beyond simply swapping steel for aluminum. The material science inside a modern car is nothing like what came off a Detroit production line in 1965. For buyers, this creates a genuine trade-off worth understanding before making a purchase. Lighter materials improve fuel economy and electric range. They can also improve handling because a lighter car is easier to control. But the repair costs on newer materials can be higher, and the long-term durability record on some of these newer approaches is still being written. A 1968 muscle car built from steel is still on the road today. Whether an aluminum-bodied truck from 2015 holds up for 60 years is a question that nobody can fully answer yet. What is clear is that the decision was not made purely for the love of aluminum. It was made because regulations demanded better mileage, because competition from global manufacturers forced American companies to find every efficiency they could, and because the financial pressure following the 2008 crisis stripped away any remaining hesitation. Detroit did not walk away from steel because it wanted to. It walked away because the math stopped working.